Hi, welcome back. This is Professor Ridge, and today's lesson on section 7.5, expressions containing several radical terms. So first off, we want to start off by how do you add and subtract radical expressions? What are like radicals? What are like radical terms? So let's start off with that definition. Like radicals. So two radical expressions that have the same indices and the same radicands, those are like radicals. So an example would be like 5 square root of 2 and 3 square root of 2. So since they're both square roots, the index for both of those, so indices plural for index. So the index is 2 square root, and the radicand is also 2. Radicand's the number inside. So those are like radicals. If I did 8 fifth root of 7x and negative 3 fifth root of 7x, those are like radicals, because again the indices would be, or the index for these two would be 5, and the radicand would be 7x. Okay, so like radicals can be combined just like we combine like terms. So example, if I said simplify or combine like terms, this expression 5x plus 3x, you're going to tell me that, well, that's 5 plus 3. You leave the x alone. So they're like terms because they both have x as your variable part, and they're the same, so we call them like terms. And then we add the numbers in front. 5 plus 3 equals 8. And we never show this step, but really that's what's going on. That's the distributive property that we're using. We just don't think about it. So if they're both x's, you just leave the x alone and you add the numbers in front. Well, that's the same thing if I have 5 square root of 7 plus 3 square root of 7. You can think of the square root of 7 as just like that x. Well, both terms have that square root of 7, so if we're using the distributive property, you can factor it out, and then you just add the numbers in front, 5 plus 3, and that's 8 square root of 7. So it's the same idea as combining like terms as combining like radicals. So if the radical portion is identical, then you just add the numbers in front. All right, let's try a few. Okay, number 10, you got 14 times the fifth root of 2 minus 8 times the fifth root of 2. And those are like radicals. So I'm going to do the 14 minus 8. And I'm going to leave the fifth root of 2 alone since they both have them. So again, it's like you're factoring it out. And you wouldn't show that step. You would just write down 6 fifth root of 2. So you don't have to show this. Unless you really felt inclined to, then you could. But typically we don't show that step. All right, look at number 14. We got square root of 6 plus 3 square root of 6 minus 8 square root of 6. And again, they all have square root of 6. So I wouldn't normally show this step, but this would be 1 plus 3 minus 8, which gets me negative 4 square root of 6. And first glance at this one, a lot of students have trouble with this because they have trouble thinking there's a 1 in front of that square root. Well, that's just like if I asked you to do x plus 3x minus 8x. We learned early on that there's a 1 in front of that x. It's the same thing as 1x. There's a 1 there. Plus 3 minus 8x, which would be negative 4x. So it's no different than that. So just like we know x equals 1x, Then the same can be true about square root of 6, same thing as 1 square root of 6. Okay? Alright, let's try. Now what's different than with variables is like number 18 is your first step is you need to simplify the square root first before you combine like terms. So we need to simplify the radicand. So I'm going to take 50. 50 is 5 times 10, and 10 is 2 times 5. So, you know, if you do a tree diagram for factoring. So I got 2 times 5 times 5 minus 4 square root of 2. So 5 is going to come out. And it's going to multiply with the 9 that's out there already. And that's going to give me 45 square root of 2 minus 4 square root of 2, which is 41 square root of 2. Since they're both square root of 2s, I can combine them. Let's look at 12. So again, I'm going to factor. I want to simplify. So 12 is 2 times 2 times 3. 16 is, or 27 is 3 times 3 times 3. Remember, square root, so I'm looking for pairs. That 2 2's inside make 1 2 outside. 2 3's inside make 1 3 outside. So we get 10 square root of 3 minus 48 square root of 3, which will give me negative 38 square root of 3. Okay, let's look at 26. So let's see, cube root of 54. 54 is 9 times 6. So 3 3's times 2. And x to the 4th is, I could do the exponent shortcut too, but anyway. So 3 3's inside make 3 cube root of 2x. We have 3x's inside, so that makes x cube root of 2x. And notice that if we're just concerned about like radical terms, technically these are like radicals because all we care about is the radical, the indices are the same, they're both cube roots, and the radicand's the same, they both have 2x. So we're going to do that factoring technique where we're going to subtract the 3 minus x cube root of 2x. And since I can't since I don't know what x is, I can't simplify this any further. I just leave it like that. So in one instance, we combined like radical terms. In another instance, that didn't really simplify it either. So it depends on how you're viewing it. Okay? So sometimes we leave the answer the step before it. Sometimes we do it if we want to combine like radicals. Technically, that's what we did here in the final step. All right, now to the next topic. We want to multiply radical expressions. Okay, so number 30, we want to multiply and simplify, of course. Now, before we do number 30 there, let's connect it back with just algebraic expressions. If I had a number 5 out in front of a parentheses, say 2x minus 8, how would you simplify this? And if you're saying, oh, you would distribute, multiply, so you get 5 times 2x minus 5 times 8, and you get 10x minus 40, right? And you wouldn't even think about it. You would skip that middle step and go 10x minus 40 without thinking about it. Well, number 30 is the exact same thing. You got a number out in front of parentheses, so what you do is you got to distribute it. So we're going to go square root of 3 times 6 minus square root of 3 times square root of 3. Now remember from the earlier section, when we're going to multiply the outside numbers with the outside numbers, there's a 1 in front of that. So it's 6 square root of 3. And then the inside numbers with the inside numbers. So this is going to be square root of 3 times 3. And then we simplify this, do 3's inside, make 1 3 outside. And these are not like radical terms, so there's nothing you can do with this from here. So you just leave it like that. Okay, I just want to make one up here. So I'm going to take 5 square root of 2 times the quantity 3 square root of 6 plus 4 square root of 5. So again, I'm going to distribute this. I'm going to go 5 square root of 2 times 3 square root of 6, 5 square root of 2 times 4 square root of 5. I don't need a parenthesis there. And remember, I'm going to do outside numbers with outside numbers, so that's 15 square root of 12, but I'm not going to write 12 because I'm going to factor it to simplify it. So 12 is 2 times 6, which 2 times 2 times 3. I'm going to multiply the outside numbers, that's 20. Multiply the inside numbers, 2 times 5. And again, I factor it so I can see if I can simplify it. So on the first radical, 1 2 comes out. 2 2's inside, make 1 2 outside. And on the second one, there's nothing I can do, so leave it alone. And of course, I got to multiply the 2 times 15. And then these are not like radicals, so you can't do anything further. All right, let's try one more. Oh, let's go on to doing number 42. So let's look at that one. 42, 4 minus square root of 5 times 2 plus square root of 5. And again, just like we did before, if you saw something like this, x plus 3 times x minus 5, what would you do? And if you're saying, oh, FOIL, or distribute, so you're going to go x times x plus x times negative 5 plus 3 times x plus 3 times negative 5. Okay, and then of course combine like terms. You know what to do from here. Alright, so that's exactly what you do. Well, if you're going to multiply two rational expressions, or two radical expressions like this, you're going to do the same thing, and you're going to FOIL it. So we're going to do the 4 times 2 plus the 4 times square root of 5 plus the negative square root of 5 times 2 plus negative square root of 5 times square root of 5, which is going to get us 8 plus 4 square root of 5 minus 2 square root of 5. Remember, outside with outside, inside with inside, minus, because I got negative 1 times positive 1, it's negative 1. Square root of 5 times 5 on the inside makes a 5 on the outside. So normally I would just write 5 right there without, so let's skip, I wouldn't write square root of 5 times 5, I'd just go 2 5's are inside, that makes 1 5 outside. Okay? So the 8 minus 5 is 3, and then these are both square roots of 5, so what's 4 plus a negative 2? So it's plus 2 square root of 5. And now I'm done. And those are not like radicals. Got a whole number and a radical, so you just leave it. 3 plus 2. Don't, I mean, how tempted you are to write 3 plus 2 is 5. You can't do that because this 3 is a whole number. 2 root 5 is a radical term, so you can't do anything. They're not like radicals, so you can't combine them. So you just write it down like that. Okay, so on this one, 3 plus square root 11 times 3 minus square root 11, when you FOIL it, you're going to get 3 times 3 is 9, minus 3 square root 11. Now you're going to distribute the square root 11, so it's 3 square root 11, minus square root of 11 squared, right? You get two 11s inside. That makes one 11 outside. And notice the middle terms, they're like terms. So you got a negative 3 square root of 11 plus a positive 3 square root of 11. So those go away. And then the 11, square root of 11 squared is just 11. So we get negative 2. And this is a special structure. If you recall, when we did a plus b, a minus b, gives you a difference of squares. So we call this, if we have square root symbols in here, it's the same technique, but the square root of a squared is a, minus square root of b squared is b. And we call this technique, these are called conjugate pairs. So you want to remember, it's just like doing a difference of squares. So if we had a square root of a plus square root of b, and square root of a minus square root of b, these are called conjugate pairs. Because when you multiply them together, it turns into a rational number. Okay, so those are conjugate pairs. Now, it's important to know that, because if you wanted to do something like 5 square root of 2 minus square root of 3 and multiply it by its conjugate, which would be 5 square root of 2, you just change that sign in the middle. Then you use this technique where you're going to square the first number minus you square the second number, and you get 5 squared times square root of 2 squared is 2, minus square root of 3 squared is 3. So you get 25 times 2 is 50 minus 3. And see, you get a nice whole number, rational number. It may not be whole, it could be a fraction. Okay? So we'll talk about this in a second. Okay, and I want to review the square formula too from when we did binomials. So a plus b squared is the same thing as a plus b times a plus b, and you can FOIL it and you get a squared plus ab plus ab plus b squared, and then combine like terms, you get plus a squared plus 2ab plus b squared. And of course we can skip all the work and just jump down to that and memorize this formula, which we should know by now, I hope. And it works the same for radical expressions. If you have two terms, 3 plus square root of 10 squared, remember the 3 is going to be the a and the square root of 10 is going to be the b. And if you don't memorize formula, just do 3 plus square root of 10 times 3 plus square root of 10 and FOIL it. No big deal. But, you know, it's nice to learn this formula. So we're going to square the first term plus 2 times the first term times the second term, and then square the second term. So we're going to get 9 plus, and remember when you do multiplying numbers with radicals, you do the outside numbers with the outside numbers. So 2 times 3 is 6. And inside numbers with inside numbers. So it's just 6 square root of 10. And then here we got square root of 10 times square root of 10. So that's 2 10s inside, makes 1 10 outside. So we get 19 plus 6 square root of 10. And nothing simplifies from there. So if you square a binomial that has a radical term in it, it doesn't get rid of the radical term. You still end up with a radical term in there. So one way that you can get rid of the radical term is you got to multiply by a conjugate. which again I'm going to talk about in a few seconds here. Let's try another one of these. 56. We got square root of 3x minus square root of 2 squared. So again, I'm going to square the first term. And normally I don't write this down, but minus 2 times the first term times the second term. Now again, I didn't write this down there, but the way you can think of it is like this. And then that's going to be negative. So that's why that middle term will be negative. And then the second term squared. So we're going to get 3x minus 2 square root of 6x. Square root of 2 times square root of 2 is just 2. And there's no like terms to combine, so that's our final answer there. And that's square root of 6x. All right. Now, rationalizing the denominator. So we talked about this a little bit. The last section, we rationalize something like if you had 1 over square root of 2, then you multiplied the bottom and top by square root of 2, and you get square root of 2 over 2 2's inside, make 1 2 outside. So that's rationalizing the denominator. Well, now if you have a fraction like this, like number 62, you got 5 over 4 minus square root of 5. You can't multiply by just square root of 5, because then when you distribute it on the bottom, you still end up with the square root of 5. You can't square the bottom because like number 56 and number 52, you see when you square it, you still end up with the radical term, so that doesn't work. So this is where you got to multiply by the conjugate. Is going to be 4 plus square root of 5. And then you're going to multiply the bottom and top by the conjugate of the bottom, because we got to multiply by formula 1. So on the top, we're going to distribute. On the bottom, we're going to use the shortcut, the difference of squares shortcut. So we're going to go 4 squared minus square root of 5 squared. So we're going to get 20 plus 5 square root of 5 on top. And the bottom we get 16 minus 5, which is 16 minus 5 is 11. And then to see if you can reduce this, remember to reduce a fraction you got to factor and cancel common factors. So we can see we can pull a 5 out of the top two, but a 5 doesn't go into the 11, so there's nothing that's going to reduce. So that would be our final answer there. Alright, so let's look at 64. I was going to do a harder one first, but let's do a medium one. So we want to rationalize the denominator. So we're going to take whatever's on the bottom, and we'll take the conjugate. So you just change that middle sign, and you multiply the top and bottom by the conjugate of the denominator. So I'll do the easy one first. The difference of squares on bottom. So that's going to be 3 squared minus square root of 5 squared, which is just 5. Top, I got a FOIL. 1 times 3, 1 times negative square root of 5. Now, so 1 times 3, 1 times square root of 5, 1 times negative square root of 5. Now I'm going to distribute the negative 2. I'm sorry, the square root of 2. So it'll be 3 square root of 2. Remember, outside with outside, inside with inside. And then square root of 2 times square root of 5. So it's positive 1 times negative 1 is negative 1. Square root of 2 times 5 is 10. And the top can't simplify anything. The bottom is just 4, so we can rewrite the top. 3 minus square root of 5 plus 3 square root of 2 all over 4. And that's your answer. Alright, let's try that 70, which is a little bit harder. 5 square root of 3 minus square root of 11 over 2 square root of 3 minus 5 square root of 2. And I'm going to multiply it by the conjugate of the bottom. So you just take the bottom expression and change the middle sign. Whenever you do the bottom, you got to do the top. Okay, again, I'll do the easy part first. So the bottom, I'm going to square the 2 square root of 3 minus 5 square root of 2 squared. Top, I'm going to distribute. Remember, I'm going to do outside with outside, inside with inside. So when I do the top, 5 times 2 is 10, square root of 3 times 3. 5 times 5 is 25, so I'm doing the next term. Square root of 6. And then I'm going to do the square root of 11. So that'd be negative 2 square root of 11. And then the last would be negative 5 square root of 22. And these two 3's inside make one 3 outside. So 3 times 10 is the 30, plus 25 square root of 6 minus 2 square root of 11 is 5 square root of 22. And none of those are like terms. None of them can be simplified, so that's pretty much it for the top. The bottom, I'm going to do 2 squared times 3, which is 12, minus 5 squared times 2, which is 50. So we're going to get negative 38 on the bottom, and then we just rewrite the top. And that's pretty much it. So it's a big old fraction. Okay, now the last thing in this section is that we're going to simplify radicals that have different indices. Okay, so this is a trick for simplifying products and quotients with differing indices. Now we're talking about radical expressions, of course. So you're going to convert all the radicals to exponential notation. From there you can use exponent rules, and I wrote and/or. You can get all the exponents to have a common denominator. Once you have common denominators, that's going to be the index for the radical notation. So then you convert it back to radical notation and use radical rules. Alright, so let's try a couple of these. So number 80, so we got 10th root of a times the 5th root of a squared. Now note, if this was using radical rules, you can't do anything because the indices are different. So what we do is we convert it to exponents, and then we can use exponent. Since they have the same base, we can add the exponents. So common denominator would be 10. So 1/10 plus 4/10. 1/10 plus 4/10 equals 5/10, which reduces to 1/2. So this equals square root of a. Okay, and a kind of surprising result, but that's the trick that you can do it. Let's look at 84. I got the 5th root of a cubed b times the square root of ab. So again, what I could do is convert this to exponents. should have been A. So now we can get them all to have common denominators. So let they'll be tenths. So 6/10, 2/10, 5/10, 5/10. So we're going to get A to the 11/10 and B to the 7/10. Now I can factor out that 1/10 and convert it back to radicals, and that's going to be the 10th root of A to the 11th, B to the 7th, and you can see that we got A to the 11th, so 11 divided by 10 is 1, remainder 1. So we can bring one of those groups of 10 A's inside as 1A outside, and then that would be my answer there. A, 10th root of A, B to the 7th. Okay, so that's the trick. Works whether you're multiplying or dividing. Let's do one dividing one. 5th root of x cubed y to the 4th over square root of xy. So again, it's going to be x. Here's another way to do it too. Instead of distributing the 1/5 to each of those, I can leave it out like that. And this xy to the 1/2. Get those to have common denominators, which would be tenths. So that's 2/10 over, actually I don't like doing it this way. So let's go back to the other way. I mean, I definitely can do it that way, but I prefer to do it this way. X to the 1/2, y to the 1/2. Now again, I want them all to have the same denominator because my goal is to convert it back to radical notations, just have one radical. So I'm going to make them all tenths, so that'd be 6/10, 8/10, 5/10, 5/10. Use my exponent rule. 6/10 minus 5/10 is 1/10. 8/10 minus 5/10 is 3/10. And since they both have the tenth as the denominator, I can make it the index, 10th root of x to the 1st, y to the 3rd. And that's my final solution there. Okay, so that concludes the lesson for 7.5. Go to my math lab and complete your exercises there, and I'll see you next time.